Dear DSA students, we are so excited to be on this journey with you, and we want to say a big well done for your commitment and enthusiasm so far. Whether you have just joined or you have been learning with us over the past few weeks, we see your progress and we are rooting for you all the way. Now, we know there's been a bit of silence around the learning management system, and we sincerely apologize for that. But here's the good news. We have an update as regards the learning management system, and it is one you'll love. Some of you may have been onboarded on the previous LMS, but want to ask that you kindly disregard any previous link, platform, or communication concerning that old system. We are officially switching to a new platform that you may be familiar with, Canvas by Instructure. For those new to Canvas, don't worry. A video tutorial will be uploaded to guide you step by step on how to use the platform effectively on our YouTube channel. You will also receive an onboarding email directly from Canvas by Instructure to help you get started. Please follow the instructions in the email and input your details to begin your learning journey on the platform. We are committed to making sure your learning experience is smooth, interactive, and impactful. So please, pay close attention to the announcements coming right after this video for more details. We are so glad to have you with us. Keep going, we've got this.
Yeah, hello everyone. Good evening. Okay, thank you very much. Yeah, good evening, everyone. If you can hear me, I'll see in the comment section. Good evening. Welcome again for today's class. Good evening. You're welcome, Mr. Babs. I think I note some people down. Benny, Lebon, Grace, Christina. Good evening, Yetunde, Research. Good evening, Lewis. Lewis. Adegoke, Kende. Good evening. Good evening, everyone. Welcome once again. Yeah. Good evening. Good evening. Good evening. So we'll be starting for where we stopped last week, and then for where Oluwole and Isaac has taught us on classification, on the splitting of data, on the evaluation performance. So anyway, we stop today, we'll continue again next week. Continue next week. So I will share my screen. I will show you one of the system I developed. Yeah, good evening, good evening. Good evening, Damilare. Good evening, World. Good evening, Igwe. You are all welcome. You are welcome to today's class. If you can hear me very, very well, and if I'm audible enough, I want to, on the comment section, you can just put yeah, yeah. If I'm audible enough and you can see my screen, yeah, yeah. Good evening. Yeah, good evening, Christopher. You're welcome. Yes, thank you. Thank you, Ibrahim. Yeah, I guess we are good to go. So what I'll be going through this slide, I believe our system is ready, and your Anaconda navigator is already open. The Jupyter notebook is open, and I believe they've sent the link for today's class, like the week 3, week 5, well, week 5, the code for today's class, right? So start practicing from there, and you have not sent it, we'll practice it together. We'll do everything together today. So my name still remain Blessing Olonfemi. I'm a machine learning engineer. I'm a data scientist by profession. Okay, so let's dive into what we have for today's class. We want to understand the process of splitting data sets. We want to understand the process again of doing train model on real data set. Train a model on a real data set. Also understand and understand how to evaluate model performance using the K matrix. The K matrix. Note there are different type of matrix for your model, different type of matrix. So you need to understand. I used to say this is a part where you do just little research, yeah. Then we gain hands-on experience on what we want to do. So for the past 4 weeks, we have been on diabetes data sets. I said something in my first, I think second class, that don't just concentrate on diabetes data set. This is just one of the simplest data set I think I can use for this class, right? So you can use other data sets on finance, on agriculture, on health, other data set on health, right? You can just play around with it, and then and you have question, you just you know how to ask. Then we'll focus on the diabetes data set. The features I said earlier is the age, BMI, blood pressure, glucose, etc. And the target variable, the outcome, get our data set from Cargo. Get our data set from Cargo. We can't see your screen. Are you sure you can see my screen? Okay, please share your screen well. Okay. Okay, can you see my screen now? Can you see my screen? This is just introduction, though we are still going to this is just introduction. But still what we want to do is practical, it's more practical. No need of I just want to okay, thank you. Thanks. Yeah. So yes, thank you, thank you. So just what we have been doing, and then recap of what Oluwole Isaac taught us for us to understand. So when I'm done with this, we're going to our practical class, right? Yeah, thank you, Emmanuel Ogunsonya. Is it Ogunsonya, Emmanuel? Thank you very much. Yeah, thank you. So now we have been, for the past 4 weeks, we've been working on diabetes mellitus data set, right? And I said again that we have different data sets that we can use. So we've done different visualization. Your own is get another data set on finance, on agriculture, even on health. Just get different data sets and practice what we have been doing. Those practices on it, right? Then maybe before I go to the practical we're going to for today, I'll show you a system I developed. I developed a system, I think this morning when I was just playing with that simulator, like I'm preparing for this class, just sharply develop a system. So if you can't finish what we want to do today, I'll show you the system. Then next week, I'll show you how the system is being developed. Right. So continuation. For this class, we've talked about Python, pandas for data handling. We've talked about scikit-learn for machine learning models, matplots, seaborn, visualization, right? Matplots and seaborns for visualization. We've looked into that, and everything about Python or model is functions or libraries. They call it functions, or sometimes call it libraries. You need to download these libraries, download these functions for your work. Now, for data loading and exploration, we talked about the import of data set, check for the missing value, describe statistical information, and visualize correlation, right? Then this week, Oluwole have talked about model sprinting, talking about models, accuracy. We talked about precision, F1 score, TPTN, true positive, true negative, false positive, false negative, everything we're going to be doing. And I'll be explaining in details. I'll be showing us in details, right? So now, I'll be saying this. I'll be saying a lot of stuff, a lot, because machine learning is wide, but we are focusing on what you need for this class, like what you need, even general, like in the world too, what you need. Now, we'll be talking about splitting of data into 2 or into 3. Splitting of data into 2 or into 3. First is so first is you need a training set, a training data set, and you need a test data set. A training data set and a test data set. A single library or a function can do that in Python. Now for diabetes mellitus, I think we have 768 instances, patients, 768, if I'm right, 68 patients, right? So a single something can divide, okay, I want to use 80% for my training, for training my model, and 20% for training my model, right? Which we'll now call it AI or anything you want to use it, your model to do. Now, this is an optional something. We also have validation. You can have maybe 70, 20, 70, 20, 10 for validation, right? 70, 20, 10 for validation. What's the meaning of that? Is you are keeping a good number of data sets for testing, for training, another good number of data sets, in particular just a minute number of data sets for testing and for validation. That is to say, when you're done with your model, this is what we're going to do. When you are done training your model or your AI model that you're developing, right, it should be able to generalize well on same data set. That is what is called data splitting. Like when I'm done training my model, you should be able to generalize well on same data sets. So we'll be showing us how it is being done because of this. I'll be showing us because of this teaching. So now this is just a simple code for data splitting. You train, you test, and you have to train and test. I know it's not somewhat clear, but for now we have this function from scikit-learn. I believe from the first class, when we say you should download the library for scikit-learn, sklearn, I call it scikit-learn, but sklearn. You download, you've already installed the library sklearn. Now, this is just doing that. So now we have strain, we have stest, we have ytrain, we have ytest, right? Okay, let me just go to this place. I'll be showing us in our code. Then we have test size 20%. So this is automatically telling me that my test data set should be 20%, and automatically telling me that my train data set is automatically 80%. If I change this one to 3, it's telling me that my test data set is 30% and my train data set is what? 70%. Right? Then the random state, which is equal to 42, is for reproduction, like to make sure that everything is set very, very well. We don't have the slides in the elements. We'll provide that. We don't need the slide, we need the code. Please, I'm just explaining. Now, why model selection matters. Different algorithms learn in different ways. Not all models are suitable for all type of data sets. Learn what your data set is doing. Know what your data set is doing. Know how maybe your data set is clean or not. Right? Is your data set clean? Your data is not clean. What type of model can I use for my data set? We need to know that. Right? So I saw something online, I think on LinkedIn, where I was working then, the difference between machine learning and deep learning models, right? So machine learning, the data volume, most times machine learning, when you want to apply machine learning algorithms, or models, they are small, data set are small, 1,000, 2,000, they are still small, minute, you can work with that. Good evening. You can work with that. Then feature engineering, most times the feature engineering is done manually. You tell the computer what to do. Unlike deep learning model, if time permits, I'm going to go into deep learning model. I want to concentrate more on machine learning model before deep learning model. Deep learning model, most models do the feature extraction themselves. They do the feature engineering themselves, right? Now, the problem type most machine learning solve is tabular data. Our data set we're working with is a tabular data set, right? The problem deep learning model solve most times is on structured data sets, right? It's on labeled, but machine learning most times is supervised learning. We've talked about that. I just want us to have more understanding of what we are doing. So when we are printing data sets in our code, you understand, okay, this thing is doing this one, this model, this type of model, I need to apply, right? Then the computational resources, most machine learning, they have a limited compute limited computing resources. Why for deep learning model have high compute? That's why we're using maybe Colab, GPU for deep learning models. Right. Coming back to our work, Isaac was saying something about classification of as a classification regression. Then this work is classification. Does do something like classification. Talking about we want to predict or detect the patient. These people that have diabetes and those people that don't have diabetes. Binary classification is 0 and 1, right? 0 and 1 to the target variable, which is 0 and 1. So there are different type of classification that we can use for this type of work. We can use KNN, and use support vector machine, random forest, decision tree. But most times I like in my class, or when I'm running my code, not in my class, when I'm running my code, I like using assemble models. I love assemble models a lot because it learns to a combination of multiple trees. Isaac taught us decision trees, right? It was, when he was explaining yes, no, the trees, when he was explaining all these trees, the combination of trees used to give better performance. Now, random forest is an assemble model. Why? Because it combines multiple trees together. Random forest is a model. Random forest is also, I can call it AI. When I've trained the model, it's an AI. I'll be showing us. I'll be showing us. I just want us to understand. So AI is something you train, and AI depend on data set. Most times, most of the AI that I've worked with, they depend on data sets. So if you are hearing random forest, if you are hearing decision tree, if you are hearing support vector machine, or you are hearing LLM, if you are hearing ChatGPT is transformer, self-attention mechanism. What happened? What did they use ChatGPT to do? Like, they just get as many as possible data set, deep learning models, many as possible data set. They train data sets on ChatGPT, on the model, but it's relying on self-attention mechanism, like patches, like how would I put it, sequence. Like, as it's learning from here, it's bringing it down, it's learning again. That was deep learning model, but we don't need that for now. So all these models, we have pre-trained models. All these models, they are already, one single line of code can do what we want to do. Train and test. I'll be showing us in the course of this class. Then evaluation matrix. You need to understand again that what you are doing, what the problem you want to solve, you should know the type of evaluation matrix you want to use. For regressor, Oluwole or Isaac was talking about root mean square error, was talking about root mean square error, R square, and likes. That is performance. You want to know how the model is performing, is predicting well on the data set you are training, right? So if we're talking about classification, we're talking about accuracy of the model. We're talking about classification, we're talking about precision, how precise the model is predicting those problems in your data set. We're talking about recall, F1 score, talking about confusion matrix. Confusion matrix actually is a confused matrix indeed, but it's very, very, very simple. I'll explain to us. That's when Oluwole was talking about TP, TN, FP, FN, right? He was talking about TP, FP, FN. So two positive, two negative, false positive, false negative. All these things, we need all these evaluation matrix or performance to know the type of, before we take the model out, before we use and develop anything you want to develop in the world, right? So you need the evaluation matrix or performance of the model before you now say, hello, in this course, DSA, I developed something, I want to use it, and it's giving me so percent accuracy. I believe if you apply it on your work, on your company, it's going to do this thing, it's going to do that, right? So that is what is for that. Then choosing and training the classifier. Choosing and training the classifier. We have logistic regression is simple and interpretable. Then the strength of logistic regression is fast baseline model. So this is where you need to learn this model. Should I use this model for this data set, or should I not use this model for the data set? Right? You need to know K nearest neighbor, classify based on nearest neighbor, That is those things that are close. You classify them. So should I use this model or should I not use this model? Easy to implement. KNN is easy to implement. Support vector machine. There are different types of support vector machine. There are models too. So there are different types. We have support vector regression, support vector machine. We have support vector C, SVC. I think SVC. We have SVC too. Different type of support vector machine. Support vector machine that we have now, I don't know, maybe they're having issues. Anytime you want to make use of it. So minimize margin between classes. It's work well in high dimension. Then random forest is a combination of plenty trees together. So it predicts well. So a symbol of decision trees combination. Also presently now, that is where you can begin to now be looking at gap. Okay, if random forest is a combination of decision trees or trees together, what of if I combine more trees and call it a name? Somebody just wake up one day and develop something, they write a function and combine different something and call it a name. And somebody called, and there's another type of model, it's called extra trees, right? You can just When we start, you see, oh, that is for deep learning model. Deep learning model. Currently now I'm working on a model. I want to develop my own model from pre-trained model, then just do 1 or 2 fine-tuning and call it a name. I just call it blessing model, or so model like that. So you can develop your own model for your own specific type. Also have naive model based on this biased theorem, good for text data with independent assumption. Now look at this first something. I'll be showing us in the code. From scikit-learn model import logistic regression. So you have scikit-learn, sklearn already import in your system. So what you just need is logistic regression is standing on its own, right? Just standing on its own. Nothing, you have not trained it, you have not done anything. So now we now call logistic regression model. We call it logistic regression model is equal to logistic regression, right? Model is equal to logistic regression. Then model fit, model dot fit this simple code. S-train and Y-train. This S-train is for the features, all the diabetes mellitus features. Y-train is the target variable. S-train is, so this simple something is training. Simple. This code is training your data set. The model is training on your data set. Simple. So what is it training? It's training 70%, 80% of the data set. No. ChatGPT is not an example of random forest. ChatGPT is an example of self-attention mechanism model. That is transformer models. Bet. Bet. So we have different type of model actually. Different type of model. Different type of model. You can just, even if you can search it now, try it out now. Type of machine learning models, type of deep learning models, and they will tell you the functions of what they are doing. Right? So random forest is not in the body. There's a way you can do that. So this model here is doing the fitting, and okay, it's doing the fitting. Then key evaluation matrix that we want to work with: accuracy, precision, recall, reference score, ROC or AUC score, and then the key evaluation matrix talking about accuracy, precision that tell us how many of the predicted positive case were actually correct, important for avoiding false alarm. Recall tell us how many actual positives were correctly identified. Then F1 score, most times F1 score is used for small balancing to check for balancing data set. Then we're working with true positive, true negative, false positive, false negative, ROC curve, AUC scores, and then all this other stuff, just to check all these things here, just to check for the performance of your model, or everything here to check for the performance of your model. Please, sir, why is X in block letter and why is not? Why is X in block letter and why is not? Okay, where is that? X in block letter. For training, okay, yeah. Do you mean this one? S in block letter, Akim, S in block letter and Y is not. When we get to the code, I will explain. But S train, Y train, S train, Y train, all of them, like just as if you can as well say, say Akim train, Akim test, right? Akim train and Akim test. You can just put anything, just like as if I've said it from the beginning, you are defining a variable, right? So it's just for Emmanuel says it's a training code. It's a training code. Just code, just know it. Just know it. I used S in block letter last week. It gave me error. Now work on it. We'll work on it. We'll look at it together. Now, that is for that. So summary is we have done this, process, perform, train, evaluate model, visualize performance for better interpretation. Now everybody go open your Anaconda navigator. So most times why I love doing taking us through this stuff for us to understand what we are doing. and for us all to, like, find time to open your Anaconda Navigator. That is Jupyter Notebook. You can open your Anaconda Navigator Jupyter Notebook, and then I believe they should have sent a link. What I did now for the week 5 code is I've cleaned everything, removed some unwanted comments, make sure I clean everything, and it's awesome now. So I'll be showing us in the code. I changed it to a small letter and it will work. Okay, then no be the capital letter they cause error. And yeah, correct. It's not about capital letter or small letter. I'll be showing us in the code. Right. So now everybody, if you have opened your Jupyter Notebook, say yeah. Open your Jupyter Notebook, go to DSA folder. Then I don't know if I can share the link so that everybody should download with 5 codes, or I believe they should have sent it to us. But if not, we'll continue from there. Okay, thank you, Charles. Thank you, Benny. Open your Anaconda Notebook. I'm doing that now currently too. So as soon as I'm dropping this slide, it will be Anaconda Notebook. But first thing first, let me show you what at the end of this class, what I'll be developing. I'll just show you the code. Yeah, thank you. You have opened your Jupyter Notebook, Anaconda Notebook, Abimbola, booting. Yeah. Thank you. Let me share this one. So I think I have a code here that I worked on. Yes. First Windows. So while you are doing this, please open Anaconda or Jupyter Notebook. Make sure you open everything. I developed something I want to show us. Okay, good evening, everyone. Please, this AI class. Okay, this one I was working on. Yeah, I will share the entire screen, then show you. Yeah, can you see my screen? Yeah, admin, please, can you bring up the screen, the entire screen? Can you bring it up? Okay, and it's coming up. This admin should please, so admin, please help with my screen. So we fly. Yeah, it's coming up. I can see your screen. You'll see soon. So while we are doing that, while we're waiting for the screen to come up, your Jupyter Notebook, just I think we're working on that with Mitus. Then scroll down. Now, what we want to do for this class is we want to share the data set. We want to split the data set into 2 for now. but two for now, right? And then I don't know. Let me. I don't want admin. Where is my screen? Screen share. Admin, oh, where are you, sir? I think yes, a little bit. It's captured. Yeah. Yeah. So just thinking of data sets, then I should explain. Admin, where are you? Help me with my screen, please. Link this stuff up and we flow. Mm, see. Well, okay. Thank you, Babs. Admin is loading the data. Okay. Admin is downloading data set for us. So what I want to do is I want to show us the system I built. So I use support XGBoost. It's a model, it's an AI model, but okay, I'll call it a model. So when we have trained a model, so I want to show us XGBoost and then how it works. I think yeah, XGBoost logistic regression first. Then I think it's going to help you for your next or maybe between now and next week. Some of you are going to be inclusive, like okay, I want to do something, I want to develop something after I've did or train my model. I want to do something. I want to show somebody that, oh, see what my model is doing at the back end, right? The AI model is doing. Then you can develop like flag system, like so we already a software developer. Imagine data scientist combination for me, um combination of data analysis, combination of machine learning, and somehow front end and backward, then back end, right? It's a combination. Um, you want to develop the admin. It is where low. Okay, let me try. Let me see if I can. While we are waiting for. Okay, thank you, admin. Thank you. So, can you see my screen? Like diabetes mellitus. Okay, I think it's coming up. The screen is coming up. Just to show you. First, to show you my face, then I'll show you my entire screen. My entire screen. So if you can see my screen, say yeah, yeah. Can see my screen, you say yeah, yeah. After this, I'm going to still drop the screen for the code. I'm going to drop the screen for the code. It also shows the code. Yeah, yeah, yeah. So now let me show you again for the last time. So now I developed something and I call it this one. I think pregnancy, let us say 12, glucose level should be 1 to 1, blood pressure should be 4, 3, BMI should be 1, this one should be anything, just put anything, then this person should be at 56 years old. Then you click on predict. So it's telling me that prediction, not diabetes. This person did not have diabetes. This patient here did not have diabetes, right? So I use this simple HTML something CSS. I'll teach you. I'll teach you how to get to do this stuff. I believe if I'm not teaching, Isaac should do, or Oluwole should take us on this stuff. So it's very, very um simple. Then I can clear and do something again. With this, I know I'm done with this class. Like, okay, I can produce something. I think the first class I show us spam detection system. Most times for every system I'm developing, every system or any model I'm training, the goal is to develop a system, to develop something, right? The front end something. Why the model, the AI model or any model that I want to work with is doing the back end, is doing everything you want to do for me. But I will have trained. So this is the goal of everything we are taking you. So when you are done and say, I'm just training model, I've seen TP, CN, accuracy, precision. Yes, awesome, it's good. I apply social model, I do fine tuning, I call it a name. Awesome, yeah, great. But can your model do something, right? So this is the goal for this class. Yeah, so thank you. Yeah, sure. We'll have a model developing. Now, everybody on your Jupyter notebook, I'm dropping this now to open to go to my code for today, train test stuff. I'm going to show us for today's class, window, and we call it, okay. Yeah. Can you see my screen? Okay, I need to enlarge this. I need to enlarge it. Yeah. Can you see my screen now? Can you all see my screen? If you can see my screen, say yeah, yeah. If you can see my screen, say yeah, yeah. Yeah, thank you, thank you, thank you, thank you. So during the week, I work on this code again. I just modify to make sure it's neat, right? So first thing again is we worked on pandas or dataset, NumPy array. Yeah, yeah, thank you, thank you everyone, thank you. And visualization for matplot for visualization, seaborn for visualization. Then I added something. So you know, someone that be seeing new stuff here. Percent matplot sleep. So what that does is keep my visualization inside this code. Just keep it there. Don't show me another place. Don't carry into another section, right? So that is what that one is doing. So now let us go straight to our run your code again, then load data set. We've done that. Check for the header. We've seen that the table. You know, I said machine learning like tabular data. It's work where and predict more on tabular data set. Deep learning model, in case you are asked anyway, deep learning model work more and predict well on the images, deep learning images, like you work it's deep on images, right? So we talked about this. The shape of the data set is 768 and the instances and 9 attributes or features, 9 features and 768 instances. I can call them patient. So look into this last week, it's third, fourth week, we're talking about this information of the data set. We've seen this, right? Who is saying Anolo Apo? Why are you saying Nene? We've seen this. Then to check for the zero, those data set, the features I have is zero. Now, pregnancy have 111, glucose have 5. I think the LLM, I think we should be able to connect to the LLM. I'll share the code on LMS, your LMS platform. We'll share the code on it. Then 5, blood pressure after the 5. Then after we now replace we play the 0 with none. When we play 0 with none, now it's showing us that there's no 0 again. No 0 again, but they're still missing column or so. So it's showing us those places we replace 0 with none. And this is it. I think we showed us last week. Then we do a simple visualization showing us people that have diabetes and people that don't have diabetes, right? We've seen that last last week. We've seen that last week. Now, then the histogram for each features for pregnancy, for glucose, for blood pressure, for skin thickness, for insulin, for BMI, body mass index, diabetes predicting function. These clothes, I just make sure I work on it very well. So just make sure it's clean. Because the last one, there's a lot of comments for you to read. But as we're going to get to a time, all these things, all this visualization, these blood reports to show outlines, I don't need it again because I already know what I'm doing. Right? I'll just write the code. I'll put the code inside what I'm doing and do all my stuff. What my concern is the model, right? But for some of us that want to do data analysis. So all these things are just analysis, showing the features, the highly correlated features to work with. Then I think last week we did median. The C check for the missing value, everything was 9.0. So now they will do standard scalar. We only have taught us standard scalar. Now see this. I did X, Y, X and Y from here. I want to start from here. X and Y. Right. If you can be typing, you can be typing. Run your code down. Then if you want to be typing, type this. But if you have done scalar, maybe I don't. Yeah, if you have done scalar before, you can remove that part. Then just type this. Just like this. Now, this thing is telling us that for X, should pick all the features. You should pick all the features. Yeah, okay. Yeah. You should pick all the features. Then Y is a target variable. 0 and 1, the outcome. Now, X is saying pick all the features, but remove 1. Drop, you have seen df dot drop outcome. You don't need outcome. So I said something that this is where the training have started from already. They say dependent and independent variable, dependent and independent variable. And this what is something depending on? The feature is depending on the target variable. So X is all my features and Y is my target variable. Are you with me? S is all my features and Y is my target variable. Now S is pick all the features. Body mass index. We'll share with you. I think we've shared it. Body mass index. What again? Glucose, insulin, blood pressure, all the features. Pick it. Y, the target variable. This one against this one. This one against this one. Then the scalar standards and you scale to scale. Today class on LMS. Okay. Please check your LMS and your squad announcement. Thank you, Mr. Emmanuel. Thank you. Today's class on LMS. Yeah, we sent it. I believe we sent it out. So check your LMS. Everything here, this thing I'm showing here is there. The code and the class. I believe it's on LMS. So thank you, Fresh. Now, then scalar. Now we are now in train test split. Train test split. If you want to type, you can start typing. Now, this first function, or I call it library, sklearn, from start typing. This is what we want to do. You will now discover that it's simple. All this train your model, test your model, play with your model. It's just simple code, just one line of code. Here you get just one line of code will do everything, right? So one line, you only just to call is something out. This function here is calling it out from sklearn. Yeah, from sklearn dot model. You have to be typing it again. I've done this one before. I have to be typing selection, import, train underscore text underscore split. Yeah, split. Right? And I put a comment here. I think I taught us the first class. Comment. Divide my data set into 80-20. I'm removing this one because I've tried it before. Divide my data set into 80-20. Now this is it. This test set here, this is the test set here, is 0.2. 0.2, that is 20. 100 divided by 20, and 20 divided by 100 is 0.2. That's 20%. Right? Now, look at this. Understand this. If you understand this, you are good to go. We have S train. And somebody asked question one time, said, "I do capital letter, small letter." Somebody said, "We don't, even though you put comment letter or small letter." This is it. Our data set have features. Our data set also have target variable, right? So what you want to do is the features, divide them, and the target variable to divide them. That is what this thing is doing. So we have S-train, we have S-test. S-train is for the features. Are you with me? If you are with me, say yeah, yeah. If you are with me, if you are following me, say yeah, yeah. Because I can calm down and explain this over and over again. If it's on this place, on this line of code that we are good to go, and you understand, or I want to explain very well, hey, we're good to go. Thank you, Simeon. Okay, so thank you, yeah, yeah. So S train, we have S train and Y train, right? So what about 75 for training, 20 for testing? Joshua, I will explain that. Joshua, yeah, I will explain. Don't worry. I will explain and I will show you. Explain. Yeah. Charles, have you come down and explain? So I'm explaining already. There's no problem. Wow. Praise. Thank you. You're in the spirit. So when I started writing this code, I just write. I don't even know the meaning. But later, as I started working and I need to fine tune my model, like, I need to devise something. So we have S train and Y train, S test. Now, this first one is all your features. BMI. What are our features? Pregnancy, glucose, all the features. Please divide it for me. S test, the target variable. S test, no, S train and the S test. Divide this one for me and divide this one for me. They are still our features, right? They are still our features. Now we have Y train and Y test, that the target variable. Again, I repeat, we have S test and S train. They are the features we are dividing. We have Y train and Y test. They are the target variable, 0 and 1, right? So now all this one is just like a variable, like we're declaring a variable, we're declaring, saying this should be a variable. And now look deep into this. We have train test split. See where this thing is coming from. Train test split. So this is telling me that, Oga, Alpha, how you do? Hope you are fine. Now I want to divide my data set into 80-20. Joshua asks, can I divide my data set into 70-25? Yes, you can do that. As anyone you want to do, but make sure that your trained data set is more than your test data set. Make sure most times, try to generalize. So he said, Oga, Alpha, how you dey? Hope you are fine. Say, I'm fine. Now, train test split. S scale, though I don't need this S scale, but because Oluwole, Isaac have taught us F scale, I need to scale our data set and Z score when we are scaling. So we still need this S scale, right? All the data sets should be scaled. Then the Y is still, I think it's still officials. I did the explanation down. Then this is what I'm going to. Text size should be 0.2. Is 0.2. That is to say, as soon as my text size is 0.2, automatically my trained data set is 80% or is 0.8. You are with me? Say yeah. As soon as my test data set is 20, automatically my trained data set is 80. Yeah. Now I want to test us. Now, if I say 0.3, what will be my trained data set? If test data set is 0.3, what will be my trained data set? So I'll know if you are following me. If my test data set is 0.3, well, correct. For that 70%, correct. Good. Awesome. Check. Can you people clap for yourself? So this stuff is very simple, Like just print it. You are supervising, correct. 70%, 0.7, 0.7, correct. That is 70%, or is that 30%? This is awesome. This is beautiful. Yeah, postbar, correct. Beautiful, correct. Awesome. Okay, yeah, thank you, Mr. Emmanuel. Now, beautiful. Now we have, okay, what of if I say, from here, this is where you can be doing what you want to do. I think Joshua asked us that what of if I say 70%, or what of if I say 2.5? Is it 2.5 or so? Or I can say, okay, 0.4. What will be my train data set? If I say test data set is 0.4, what will be my train data set? Somebody have already known the code sharp sharp. He said SK is not defined. So SK not defined. Anytime you see SK is not defined, you have to go back. No, if test size is 0.4, my train data set will be 0. If test size is 0.4, so this is it. Let me explain again. It's just like as if you are doing 30%. Like, okay, I visited, let me say I visited Yetunde, how you doing? Hope you are fine. I'm working on a gate now. That gate is 100,000 naira. Right? The gate is 100,000 naira. So let us share it. So it's like this. So if I want to share it now, I say, Yetunde, your own should be 30%. What's 30% of 100k? 30% of 100k is what? 30% of 100k. No. Yeah, I do not do that. Joshua, I don't do that. I don't do that. It's for forward and backward feature selection technique. I said I've listening. 30% of 100k. 200k or 30k. Okay, 30k. Okay, I've seen 30k. So it's 200k. So Joshua, I've worked on this code again. Like, I will work on it. I just want to make sure it's simple, right? So maybe later on, maybe when we ask question, we ask you to um to pick the most important features. The 30% of this 30k. Now, the remaining percent you do 70%. Correct. So that's what we are doing here. That is what they call train set and test data set. Train and test. Simple. That's what we are doing. Right. So we also have random states. Random states, which is equal to 42. Most times I increase my random state. So this one is just a possibility, just to tell my tested and tested and vice to make sure I can reproduce it in another place, in another format, right? So that is what that one is doing. But we don't need this most times. I don't need this, but because I want my code to be awesome, I put random state. Then stratify is still telling my features, the X and Y things to be okay. Now what I just need is the train, split, and Y and test set. Or this is what I just need, right? But if you want to work, you can add your random state and stratify. So what I just want to explain. Now, somebody said that scalar is not defined. And I said that before you go to this place, make sure you have defined your scalar. Make sure you have something. When you say something is not defined, when you are running machine learning or we are doing anything on Jupyter notebook, most times I say something is not defined, go back and check all your codes. Have I run this or something? Have I defined this or something? Did I need to define it? Hope you are with me. So make sure you define everything and it work. Now, before I can't install SQL and I have not been able to use SQL. That's my code document to use SQL package as depicted. I've defined my scalar, but the error says incomplete inputs. First fit sklearn. There's a way you can import there's a way you can download sklearn. There's a way you can download it, right? So you can download it, or nonetheless, okay, another one person says there's a way that people in school, I say scikit-learn, not sk/learn. Then for Dockers, I define my scalar. Check your LMS. This code is there. You see it, then you can work with it. And for some of us that are following me, you can work on the code. Now, okay, yeah, I did the explanation. SKU, these are the features, inputs like glucose, it's scaling all the features. The Y is for the target variable. This one is 20% random state. Ensure you get the same sprint every time. Then stratify to make sure the division of diabetes is diabetes and not diabetes. So though we don't need that, but we're going to work well and work awesomely, um, awesomely well. Now, I say something here. I said, think of the full data set as a class of a student. You want to test a student, that is your model. You want to test a student, your model in a class. So you teach your student with 80% of the notes. You teach the student with 80% of the note of the notes. AI, you teach the AI model or anything you're doing, you're developing with your data set. You teach it with S train and Y train, the features and also the target variable, right? Then you also test them with 20% of the notes they have never seen before, right? So that's 20% and 80% and 20%. Like you have a note, you teach them, then 20% you teach them. Like I've never been, that is S test and Y test, right? Then you now grade their performance to see if they really understood the material. So that is what this code is doing. The SK, the S train, the S test, and like so now let's see yeah, to now confirm if truly this is working. To confirm the training set shape. Now you can calculate it to your own end. You can do the calculation in your own end, right? You can do the calculation in your own end. I used to say if um if I'm dividing my data set into 80, we have 770, 768 abi. So 70%, 80% of 760 is what? Is what? So you can run the code in your own end. Let us see what it's going to give us. Of 700 and okay, correct. So it's 614. Yeah, correct. Correct. 614. Can you explain random states, sir? That is 42. I said it to 42. So it just, and also it's just more of control randomness. It's control the randomness of when you're working with train test and white test. So it just control it. Just like a seed for random number. Like how will I put it? How will I put it now? Just it's how control the randomness your of your train set and the test set, right? For it to be reproducible, for it to be reproducible. 1614.4, 614.4. Okay, is when you run this code on your system, is it giving you 614.4 or just 614/8, 8? Oh, it's time for break. Okay, so it's time for break, time for attendance, and just this 5 minute break to take your attendance. Then we'll continue from here. Thank you. Yeah, thanks. Okay. Welcome back. I believe we've taken our attendance. The code is on MLS. Yeah, it's on MLS. So what you just do is download the code. Um, take the code week 5. We upload the code every week. Every code we want to use. We make sure we upload it. So as I'm explaining, you are seeing the explanation, you are working with it. So download the code and okay. The code is on your MLS. Put the code on your inside your folder. So put it inside DSA folder you've created on your desktop. I think it's better that way. So we'll be looking at it. I'll be explaining. Then you can be asking a question. You are looking at the code. You are playing with it. You are working with it. There's something I put inside the code. XGBoost. You or you are going to fine tune your own code. We tried code is not on LMS. It's there. Yeah, thank you, Jumoke. Thank you very much. Thank you, Jumoke. Thank you. And for some of you that have downloaded it or if you have it already, you can share with your friend. Please. So okay, so I believe we've taken attendance and then let's continue from where we stop. Please check the comment section. Jumoke said the code is already uploaded. Week 5.ipynb. And someone said you should check the description. You see the code there. Someone says it's not okay, just added times. Okay, thank you. Okay. Where did we stop? The random state just allow the code to be consistent. Yes, without it, you get a different splitting of the code. Every time you run it, with it, you get the same splitting. Yeah, sure. And it's not compulsory to use random states. Most times it's not compulsory, but most times I love using it for, especially when I want to use assembly models, right? So now if you have downloaded the code, you now have the code on your system and you have opened, just go down to the train set shape, just go down. You can say yeah. The code, if you have the code already with you can say yeah. Yeah, thank you, please. Yeah, goodness, thank you. Prosper. Why is it mainly? Because I want us to follow what I'm saying, follow it together, not just stay and be typing too. Yeah, thank you, Richard. Yeah. Thank you, Jumoke. Thank you. Go to LMS, download the code, put the code into inside your folder, inside your DSA folder. Go to Jupyter Notebook and open week 5. Open week 5. Open it before I continue. Yeah, thank you, Riz. If you have downloaded and you have opened it, yeah. Thank you. Yeah, thank you. Yeah. So to get to a part, I think in the last part of the code, you've seen XGBoost, something is not installed or like. So I believe you should not install XGBoost by now. People install XGBoost. So it's one of the models that I want to work with. Now let me continue. Let me explain for us to understand what we are doing. So now again, I said that thank you everyone. Thank you for the prompt response. You are all doing well. Now I need again to still know the features I'm still working with. I still want to know the target variable from the. So I said this actually is the features, S train and S test. They're all features I'm training my model with. S3 and S features. They're the features I'm training my model with. The Y train and the Y train and Y test is the outcome, the target variable, right? Is the target variable. So if you get here, what you do if you have opened the code, make sure you run it from top, run everything from top. You will discover that this one is more neater than on 5 because I need to explain. I have to put comment to explain what we are doing. For this one, I just straight to the point. Now, run this code on your system, and let's see what is going to give you. Yeah. Thank you, B. Thank you for downloading the code. Okay, yeah, thank you. You've won it. Hey, this I think this is awesome now. This is okay. This is what we're going to be doing. When I'm done with the code, I'll send. We'll upload the code on the on LMS. Then everybody should open it. That's what we'll be doing now. Everybody just open it as I'm explaining their own, and I'll be asking questions. Why can't you do so something? Add this to do this model. I think that's what I want to do now. Correct. Okay, for being access denial on my canvas. I also have issues with the LMS, graphic design instead of AI. Okay, yes, it's very effective. Correct. Thank you, Postpad. Yeah, this is what we're doing now. I'll just be explaining because what we need is just explain the code, explain what it's doing. Yeah. Oh, thank you, Will. Thank you. That's awesome. That's awesome review. Perfect. Now let's continue, please. So I've explained all these. I said, reward. You train using 614 flashcard question plus correct answer. I've explained all this. We don't need this because of time, because I want us to do something. I want us to do something unique. And I'll wait for all of us that have downloaded the code. Now, training a basic model, step 12. You can scroll down to where step 30, a basic model, logistic regression. You can as well say logistic regression is a model or my AI model now. Logistic regression, my AI model, and I've trained. So, and I want to use this in another place. Now, see how I call this logistic regression. You start with logistic regression, it's not baseline for binary classification. Now, see this on like 18. I said from sklearn model. Now this sklearn, it has a lot of function inside. That is why from this sklearn linear model, I need logistic regression. Simple. I need logistic regression. I don't know the other model that sklearn have. Maybe I don't know if it has support virtual machine. You can try that. We'll work on support virtual machine today. You can also try other model that Oluwole have talked about. I think random forest. Random forest is not in this code. You can try we have a lot. Naive, support virtual machine. Okay, before I even continue, based on what we have been saying, we're talking about model. Can you list just two types individual now? There are two types of models that you know, machine learning models or algorithm. Yeah, okay, let me call it algorithm or machine learning models that you know. Anybody, like apart from logistic regression that you're looking at here, is there another model that you have been hearing about? Another model that you're hearing about? Anybody? Random forest, team learning, yeah, correct. Decision tree, we will use decision tree, KNN and random forest. Awesome. We will use decision tree in this class. Penalize regression. Have I heard of this model before? I'm interested. Lydia, I'm interested in that. Is it parallel relation? It has went up. XGBoost, survey version machine. When I was doing one of my work, one of my their research work on, I think it was on diabetes mellitus, I came across, I was like, I don't want to use model that is common that people used to work with. I come across CAT. T-A-R-T. Is it? I've forgotten. Something regression something. And I work with the I work with the that model. So different type of models. We have linear regression, polynomial regression. Is it a model? This more statistics stuff. XGBoost, yes, XGBoost, K-means clustering, XGBoost, yeah, linear regression, beautiful, beautiful. Now, all these models, when you call it from yeah, GAN, yeah, it's a model too, light XGBoost storage. All of you that have mentioned all this model, all of this model, eh? As I'm saying it, ANN, XGBoost, you will apply it in your code today. You apply it to your code and you tell me the evaluation performance of your evaluation performance of your accuracy. Okay, I think we'll do accuracy. You tell me as I saying all this model. Artificial neural network, ANN. Okay, RNN. RNN is for more bioinformatics. Bioinformatics. I'm presently doing something precision medicine. RNN, using RNN model. Okay, now let us continue. That's beautiful. Now, all these models is inside, just like one function can call it. So now we have inside it, we have logistic regression for inside SKLM. Now, I also did another model that I want to know the classification reports. Just this inside SKLM matrix. I did the classification report. This classification report is for the accuracy, the F1 score, the precision, which one again? Support. Yeah, I need it. Confusion matrix and accuracy score. So this is where it's coming from. Now look at this. This is what I'm going to. The first one say model. I can as well say Akin, or I can say who again is it? Yetunde. I think I used to say Yetunde, or I can say real. Real is laughing. Yeah, real. Or which should I call? Real is equal to, it's a variable, real, but I call it model, is equal to logistic regression. Now, I can say model should be support vector machine. Like, call this thing back, this logistic regression, come here, ID, hope you are fine. Please come here, I want to make use of you. Simple. And model.fit means that train my S features, train my features, and train my target variable. Simple. We are good to go. This code has trained it, but you want to see results, right? It is when you are using deep learning model, you now be saying, guys, deep learning model is epoch. You now be saying how it is training. 1, 2, 3, 4. So machine learning is one of the most simplest. Getting to deep learning, you have to be learning epoch 1, epoch 2, epoch 3. That's what I'm doing for one of my research now. I'm working on breast cancer, right? Like when I be dice two models together, I'm looking at it. Sometimes it take long computational resources and the like. So it's very it needs to take long. So now this small model, this model.fit is doing the S train and Y train. Simple. And when I run this code, some of you is going to show that, oh, I'm working with logistic regression. It's going to show this stuff here, right? It's going to show this stuff. So this is training you want to test, you want to do this one, no. That small code is doing that, right? That small code is doing that. Now we have okay, I have an explanation. If you have downloaded the stuff, you'll be seeing the explanation here, the S train, the Y train. Well, I want us to do something today. Now, when it has trained my Y and S train, I scroll down. Let me scroll down. So I'll be predicting the test. Now, on this is the model, right? This model, and I'll call back the model. And I'll say Y predict. I can as well say predict. I can as well call it another name, right? But Y underscore predict is equal to model predict on test variable. That is to say, you have trained my data sets. You have trained my features and target variable. I've divided it. That is the 6-1. This is 1-4. We are right here. The 6-1-4. You have trained and do everything you want to do. Now, I want to apply it on the test set. That's what is happening there. I want to apply it on the test set to see my results. Simple. Will my model generalize way? So that is what we are doing. And yes, please, yeah. Epoch is the number of the training cycle, yeah. You are training one by one. I wish we get to deep learning. But let us finish this one. When you get to deep learning is awesome too. It's okay, beautiful. So let me continue. Model dot predict test. So we are bringing in the model this year, this year, this year, this model here. After we have trained, right? Now come back, come and test it on my test data set. Then I've done the explanation. If you have, I don't need to explain again. I believe you are good to go. Now after we have trained, I want to see the evaluation performance of my model. First, the accuracy. I want to see the precision. I want to see the recall. I want to see the F1 score of the model if it predicts well. You can see now 0, 1 of the model. Can this model predict very well on this data set? Is there anything I need to do on this data set to be sure it predicts very, very well? Yeah, Joshua, just like that too. Just like that. Just like that. So now, looking at that, evaluation performance, accuracy. Just print the accuracy for me. Let me see. Accuracy of the Y test and Y predict. Give me the accuracy of the Y test and Y predict. It's giving me 70%. Last 4, 5, last 7, let me see, 8, 10 years ago, if you give me accuracy of 70% in my class, I'll clap for you. I'll clap for you. But now, you give me 70%, I'll be looking at you. But give me 80%, I'll like, okay, what have you done? You clean your data set very well. What have you done? What did you do to your model? What do you tweak? What do you remove? And the likes, right? Accuracy, that is so that my model train way on diabetes mellitus, but 70% is small, but maybe say 80% and above. 80, I'll tell us what to do actually. Guys, I think next week is upper parameter tuning. We'll be tuning the model, working on the model. Right. So that's for that. Simeon, are you with the right notebook? If you are with the right notebook, the S10 should not be defined, it should be defined. Okay, so now, so I said print classification reports. Let me explain that again. Classification report for 0 is what? There's no diabetes. 1 is diabetes. That is what this one is giving to us. Precision. 0 is diabetes, 1 is diabetes. Now, look at this. It shows that the model predicts where on non-diabetes than diabetes. Right? That is seeing non-diabetes more than diabetes. Why? All of them are high. Precision for diabetes is 75. Recall for diabetes is 81. Recall is awesome. F1 score is 78. Support. Now, the meaning of support is, this is why I used to catch my student. Like, do you fabricate something, or are you whining me? Right? In the sense that the support is not the total number of test sets that I'm working with. For example, I have 100 here for 0 for non-diabetes, then 54 for diabetes, right? So 100 or 54 is what? 154. Now let me go back. Let us be sure if it is 154. Correct. The test set when I put my prediction is what? 154. So it's correct. So that is for that, right? Okay. Instead of the call precision for score separately classification, to combine it all for us. This is woo. Okay. Yeah, Paul is telling this is wow. Is it wow or woo? So it's very, very simple actually. So this is what we'll be doing from now till we are done with this model prediction. I believe we have not clean data set analyzed. We don't be predicting, we don't be playing with our model, fine-tuning model, playing with our model. Then before the end of this course, we should be able to use that model to do something, right? To develop a stuff, be able to work with that. Okay, now we also have the accuracy. The overall accuracy is 70%. I don't like this actually. But because of this class, and we want to see how it is working, then when we start applying upper parameter tuning, we want to see if the accuracy is going to in Yoruba, they used to call it bera. We want to see bera the model will better. Maybe it's going to see more of non-diabetes or diabetes very well. I want to see if it's going to work well. So this prediction we are predicting, we are detecting, right? Now the micro average, we also have micro average and the weight average. So this is more of like this one plus this one divided by 2. This one plus this one divided by 2. If I'm right, I did the explanation down. The micro average and the weight average. The weight average of the model, of how the model it's been done. Then okay, this is an explanation, but I don't want. What I want to do is now. What I want to do is for everyone, if you go down, I got 71% in my spirit flame. Yes. Some of you can even get 80%. Yes. Some can even get 90%. Yes. Yes. Now, this is where compositional cost is coming in. The system you are using, how fast is it? How fast is it? First of all, are you using Kaggle? Are you using Jupyter Notebook? Are you using Google Colab? Your system. Sometimes you look at your system, then how accurately, spirit flame now, instead it goes 91%. Then I'm getting 70% here when I run my code. Maybe spirit flame, I don't know how good you are. Maybe you have done something in his code up there. I've just maybe do one or two stuff, just fine tune. Okay, what if I do like this, if I did like this, right? So spirit flame, I love what you get, and then should I be worried if I got slightly different value from yours, like from zero outcome? No, don't be worried. No, it shows that no. Is it a Donny? A Donny, yeah. Is it? Did I pronounce your name well? Single. Don't be worried. In fact, you are doing well. There's something that you have done that I have not applied to my work. Don't look at that. Or is it part of the randomness? No, no, no. With the value change for some reasons, or this is okay. Faith. I'm not enjoying today's class since it's since I can't run my code because I can't install SQL, and also I don't have access to LMS to why Faith. You don't have access to LMS, you don't have access to the code. Faith. It is well though. Um I'm unable to fill the attendance link. I think check the attendance link. I'm also on my and got 71. Okay, simple. Now there's another one down because I want us to do another one. There's another one down. I'll explain all these things again. Just scroll down, scroll down, scroll down. This TP, TN. I don't know if time permit. I'll explain this. TP, TN, FN, FP. This is how I used to catch my student too. If actually they don't do magu. Right. So this is the code. You sit inside your code. Sit inside the code I forward to you. I'll explain this for you to understand. Right. Then there's another one. I did another one for XGBoost. XGBoost. Now, don't run line 24. Don't run line 24. Line 24 is I will still go back to logistication and explain for us again. Explain for us again. Most times what I used to do is I want to make sure my code is working fine. Then I'll test it inside Jupyter Notebook before I develop a system. Right. So for this one now, if I run it, it will be showing that enter one, is it diabetes or non-diabetes, and give me that sure. Now, this is what I'm going to. From XGBoost, import SGB classifier, XGBoost classifier. Then same thing, was those same thing. If you run it, when I ran this XGBoost, I got 77% accuracy, right? Then I think it's generalizing where zero still predict well on zero and not on one. So can you please scroll down and run XGBoost? Then we'll go back to explain confusion matrix, and we are done. Okay, please, my canvas. They are telling me that I can't import classification report from SQL. What do I do, sir? I can't import classification report from SQL. Whoa, SQL classification report from SQL. Please check your code, Dave. Check your code. It's mine. If you can see my code, the code I gave to you, is it? If you have not altered it, it's supposed to work. It will work. It will work. Tell me why. Why you lost? Eh? this class today, everybody should have the code, but I want everybody to do something, or not the less, not the less. We have we have um we have this form logistic regression, classification reports, import classification reports, confusion matrix, and accuracy score. Then model. Now open, just press if you want another line on your what they calling it from that logistic regression. Just press on your system BBBB, like just B, give it more line BBBB, BBBB. Now, for those that are following me, I will attempt to some of these questions I'm seeing. My range of accuracy will you consider as good enough? What range of accuracy will you consider as good enough? Currently now, because of how things are fast, 80% and above. This is an above. You should be able to generalize where. Generalizing where maybe dropping down to 70 or yeah, or 90%, just 90%. But if you're getting 100%, instead you have to justify. For example, thank you. For example, for one of my research work, I worked on diabetes similitude. Then I combined BBB, yeah, ISIC, press BBB. I'll tell you what I want to do now. So I combined different models together. I call it parallel and sequential assembly model for one of my people. Then I did some fine tuning. Like it took me 1 year to write the code. 1 year to write the code, like fine tuning. Do you know why I did that? I was like, when I want to start the research, I was like, nobody used to get 100%. Oluwole was talking about 100%, that if you're getting 100% your model, something is happening. Can you justify it? But you can justify you are good to go. So I like, nobody have get 100% before. But I want in Nigeria here, I want to write a paper, I want to write a code that I'll get 100%, and I will publish it in one of the high impact journal, Nature. Right? It was not easy. Right? So when I'm done with the code, done everything, when I started, I was getting 97%, 79, 80 something. I started fine tuning, doing one or two stuff. When you get to a particular meeting, you will see what I'm saying. So I started fine tuning. After fine tuning, it was now increasing to 80, 90. Then one day I saw 100%. I was like, okay, how did I get the 100%? So I saw 100%. So I did some stuff in my code. It's a secret, it's a code, everything is code. Then I sent it out. Now, it took me 1 year to write the code. It took me another 1 year for these guys to approve the paper. 1 year to approve the code. Because they have like, how will this person have 100%? Professor, different people, they were like, we want to see what you have done. I started fine tuning, working on the code, send it to them, they will run, they'll say, no, this thing is changing, analyze. They have to approve. So as I'm taking in this stuff, what I'm trying to say is have backings, like know what you are doing, right? Now, my logistic regression gave me 70%. Someone said he gave you 91%. You can now come up with, maybe next week, I don't know. Now come with, okay, what can I do to get 80 something or 90 something? What can I do? What is missing? Right? This is where LLM come. You cannot ask me, you can ask ChatGPT, you can ask Oluwole or Isaac. Oh, so something, this is what I'm getting. What can I do to increase this stuff? Somehow it overfit. It overfit. I won't like overfit is on place. But this I applied a parameter tuning to my code that it was not overfitting. It was so high. I almost want to blow my system. Somebody said my kernel or something like that. My kernel went off. Yeah, it went off. I blew about 2 or 3 systems because I was doing everything on the Jupyter notebook. Now, this is what I'm going to. I want us to do this from sklearn. By next week, I should be able to explain function matrix. Then we'll write a code from sklearn. Now look for another model. Just look for a general model and look for how to call it. I won't tell us how to do that. Let me see if somebody can do that. Okay, let us do. I have XGBoost down. Let us do random forest. Let's do random forest. From sklearn model, import random forest. I don't know if random sklearn is inside random forest. Let me check. Random. From sklearn, import random forest. You don't need this one because we already have it already. From sklearn.matrix import classification report, we already have that already, right? So, okay, yeah, we have random forest. Correct, correct, correct. Now, this is what I want from you. Everybody should do this. Everybody should do this now. Just like I think from here, yeah, okay, from here, just B. Then from this is what I want from you. From sklearn, this is the dot assemble. Random forest is an assemble model. From sklearn, I'm running this. I don't know if I've run this code. From sklearn dot assemble, or my professor used to call assemble, ensemble. Import random forest classifier. Import random forest classifier. Have you done that? If you are with me, if you are following me, say yeah. We'll be addressing all our questions. I have a question about the glucose features in relation to outcome. What matrix was used for the glucose? Is it passing blood glucose or random blood glucose? Mr. Shegun, fasting blood glucose or random glucose? I'm trying to understand your question. Yeah, okay. Okay, I'll come back to your question. So we have, okay, thank you. We've typed that, correct. Yeah. Now, run this from sklearn dot assemble. We want to see if this random forest is going to increase. We're having 70 here, right? Now, model, or let us say model 1, let us call it model 1, is equal to, let us see, let me see how I did my own here. I'm coming back. See the way I want to train a model now. It's equal to train your model. Model is equal to what's random forest? Yeah, random forest. Close brackets. Then model, hope you are following me. Model 1 dot fit, open bracket, close bracket, x underscore train, capital letter X now, x underscore train. Oh man, I don't type like this. So. Then y underscore train, right? Train. Okay, so it shows that I have trained my model. I don't need this again. Y underscore train, right? So if you have done this, I've done this, model 1 is equal to, yeah, correct. Thank you. Yes. Correct. Now let us now do we want to predict it on the test variable. After we have done s that was trained dot fit, we are training now. We want to test it. We have trained, we want to test it on the test set. So let us say we have, I'll just change this one to model 1. I'm changing this one to model 1. Then run. Then look at the classifier. So what's changing here? The 1. Okay. Yeah. For my, then I want to check for the under it. I want to check for the accuracy and the, you don't have access to the data set. So I want to check for the accuracy and also precision analysis. So under it, I got 75. but this one is giving me 70 accuracy. This one is giving me 75, approximating 75. Then it predicts where on diabetes mellitus is predict well on what they call it non-diabetes. Right. So for those that are following me, let me look at your let me know your answer. I think you can get 76 or so. Let me know your answer. You are following me. I would like to know your answer. We have smart. This is not simple. Not okay. So what is giving us? What is giving us? I got 0.71. How do you determine that it predicts well? Now from your accuracy, you begin to know. You begin to see it from your accuracy. You begin to see it from your from the 0 and 1. You begin to see the scores if it is increasing or is decreasing, right? For example, now I want this code and I'm having like 60 something or something. That should that my random forest is not doing anything. It's not predicting anything, right? There's shouts, you're still getting 71. I got 75%. Spirit Flame. Awesome. 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 I said today is for gifts, so now if you answer my question very well, I got 75 correct. If you answer my question very well, I'll give you free credit. All is well. This is beautiful. This is beautiful. So for some of us that are still trying to, I got 73. Okay. System. I got 73. Okay. I mean Bola. You don't forget. You don't answer my question. I mean Bola, I think you're the one. Yeah. See, you said you're going to remind me. All right. Okay. Okay. Why do you pause? So this is what you do. This is what you do for me. For some of us that are still trying to understand, because I know you are seeing double, like I see you are seeing different code, double, like I was this. Go back to this video, watch it over and over again because I've said a lot and a lot. Said a lot codedly. I've said a lot codedly, and then also I've the code is already on LMS. So as I'm talking, be running the code, be running it. Just put the week 3-5 code inside your folder, open it in Jupyter Notebook, be running it over and over. Look at and make sure again that I explain each lines of code, what they are doing, S train, Y train, and the likes, S test, Y train, everything I've explained them, right? So you shouldn't have problem. Like painting now, thank God that the code is already available on LMS. You shouldn't have problem again. So now let me quickly explain something before we go. Yeah, I think let me go back to there's a question that Mr. Shegun asks, talking about also I have a question about glucose features in relation in outcome. Glucose features in relation to outcome. What matrix was used for the glucose? Is it fasting blood glucose or random blood glucose? For again, no, we are just doing what we're doing currently is just normal data sets. We're working with eight data sets. So I think there's nothing like for now, nothing like plus fasting blood glucose or random blood glucose. Right? Because I'm trying to estimate as trying to look at the question. Then it's like fasting blood glucose or random blood glucose. There's nothing like that. What we are doing is get your data set. In our model, want to build a model, want to build a model, fine-tune the model on different type of data sets. But you still need to understand what you are doing. You still need to understand your data set. Yeah, blood glucose of 122 is diabetic. Why random W also same value is not diabetes. I saw 122, 122 for fasting W. Where is that? Why same for random? Mr. Shegun, can you show me? Maybe I think is it in line with my code? I would like to check by date time. But before then, let us do okay. Please, if you have this code, I've explained all these things like awesomely. I even put Ojo, like I put MSPO inside. Like if you're getting something, you can check your data set. Do you want to apply smoothing on a sampling? Like you want to balance the data set, okay, you can apply that. So I've explained all this one where you have 0.8 diabetes, you have this one 0.9. I've explained this. So I need to explain this one again. What concern is now this confusion matrix. This is the code for confusion matrix, right? So for I think it's for logistic version. Why test and why predict? Why test and why predict? Give me the confusion matrix for this. Right? Oluwole have taught us. Now, if you plus, if you 81 plus 19, 81 plus 19. Let me do that too here. So I'll explain. 81 plus 19 plus 27 plus 27 is giving me, it will give me 154. 154. Okay, from there, I'll check necessarily. I'll check if time permits, I'll check, then we'll talk about it. So it gave me 154, right? 154. Now, this place here, confusion matrix, don't be confused. This will be TP, 2 positive. If this one is 2 positive, this one will be 2 negative. If 81 is 2 positive, 27 will be 2 negative. Like, is it that one now? We are that it. Then if this is false positive, this one here will be false negative. False negative. That is to say, in general times, my model was able to predict 2 positive of 81. In another form, you can say it predicts 81 patients that they don't have diabetes. And the actual sense, they don't have 2. That is 2 positive. In the actual sense, they do not have, or they do not have at all. So when it gets to, let me just explain like this. When it gets to false negative, what does false negative means? That is to say something is false and it's also negative. It's predicting falsely and it's also predicting negative. That is to say, the model predicted for those people that have diabetes or no diabetes, it has how I put it now. False negative is something is false and it's also negative, right? Okay. Something is false and it's also negative. So we have false positive. False positive. Something is false, but it is positive. We have true negative. Something is true, but in the actual sense, it is negative. Okay, let me explain like this again. Something is true and it's positive. Yes, it is true, but in the real sense, it's still positive. Right? Something is false and it's negative. Yes, it is false, but in the real sense, it is negative. That is to say, it is false, but in the real sense, negative. And something is false positive. Yes, it is false, but in the real sense, it is positive. So be looking at the last part. That's what I'm saying. You'll be looking at the last something. False positive, true positive, the positive yengongo. I'm speaking over already. Is that last something that in the actual sense, this is what is giving us. Right? Now, most times when you want to know again if the something is predicting your test data set, like the total, the support, I want to calculate everything together. It's 1 plus 19 plus 27 plus 27. So though I did this description down, thank you, Joshua. Answer. Are decision tree the same individual model that are assembled to give the random forest? Yes, please, yes. Combination of multiple trees will give us random trees. Computation of plenty trees, plenty trees for random forest will give us extra trees. Extra trees. There's something called extra trees now. Also, the combination of trees, now we have other boosting. We have gradient boosting. We have support, no support version is not trees, individual models. So all this combination will give us all this. Yeah, thank you, Tunde. All this stuff. So I did the explanation. If you have the code, I did the explanation of the H1, the true positive, the false negative, the F1 score. No, F1 score, we have not gotten to F1 score. F1 score is for balancing. So I want to round up. I want us to do nothing, but I want to round up so that I will just start. I like starting like afresh. Explain what all these things is doing. Again, maybe by next week when we want to apply a parameter tuning, right? So if you can run this code, just run the code, play with the code, all the comments, and I did all the explanation inside the code, the explanation inside the code, and then I worked on XGBoost too. I ran the code. Then after running the code, XGBoost gave me 77. Another person can say, okay, if Mr. Blessing is doing this code and something is increasing, this something is generalizing where is increasing. Now, if I just show you S predict, if I change this one to S train, Y train, and just Y train alone, right? You will discover that it will generalize where, because the more sometimes model is to feed on data set, the more the data set, the more the learning rate, it will learn well on more data sets. So this is going to increase, but the test set, is it generalizing well on the test set, right? So somebody can come up with, let me use decision tree too. You can do that. Come up with decision tree. Somebody can come up with support vector machine, look at the accuracy, come up with what again? Different type of models, XGBoost, random forest, CAT, support vector machine. I've said that they are normal models. Apply it and see what it's going to give you if it's predicting well. Then look at the comments in the code. Look at how I comment it. Okay, when this one is this one, what is it giving me? Okay, this thing is predicting like this, it's predicting like this. Can now sell this model to people? Can I tell that I have a AI model that can do this? Right? Okay, but make sure your when we start applying a performance, it is going to create. So make sure your model, at least if you send something like 70% for me, I will mark you. I'll give you your mark 70%, but 70 is okay. But like there's something you can still do on your model to increase it. Now, okay, this support function matrix for XGBoost, function matrix for XGBoost. Then I want to check for the ROC curve and the ROC curve and logistic regression. So most times you don't use ROC curve, AOC curve in machine learning. We use AOC, ROC curve in deep learning models, to check how the epoch is training. The ROC, how it's moving. We want to check the AUC, and most times we use AUC for healthcare data set, right? Because it's more of, it deals with precision and recall. So all these things you need to learn. My data set, what type of performance down to use, evaluation performance down to use on this data set, evaluation performance on the data sets. But in this class, we make sure we're teaching you everything: accuracy, F1 score, precision, and all of them like that, all of them. So I think, yes, the next class is yes. So there's something I put in this code. I commented out. I said, based on my code. Lastly, look at this. And let's look at this. For some of you that have the code already, make sure you run it to XGBoost, and then try decision tree, try naive, try support vector, try different models, train as many models you want to train. But now look at this last one. Something I did there. I said import the job lib. That is to say, let me remove this. I used to say, save my model for me, this XGBoost model, because I love it. I just love it. 77% accuracy. Wow, it's almost 80. It's awesome. Let me work with it. Save it as this. This pickle, XGBoost diabetes pickle, that is what I used to develop that system that you saw. So the backend, the AI model is doing everything. When I enter glucose level, precision level, and then I click on predict, to be able to tell me that, oh, so person now, but I still need to work on it. That because of so confident level, or because of so accuracy or so, I want need to put up the accuracy scores or confidence level. But because of this, see doctor. But because of this one, we are okay. I think I'm going to add that. The more I keep working, I'm developing. Okay, let us just use the remaining 4 minutes to answer question. If you have any question, I think next class is upper parameter tuning, apply course validation. What I'll do in next class is, if possible, I'll start all over from split test. I'll spend all over again, then go to upper parameter tuning for us to understand, just like you guys to do, for us to understand everything Oluwole or Isaac is taking us, or make sure we are infecting it in our code. So if you have any question, or you are facing any error, please share with me. Let us see if I can see answer between now and next 3-4 minutes. I'm very happy. I'm very happy that we have the code, so it will make the class to be fast. Yes, Kolade, Afolabi, how will you add another data set to another diabetes data set? Yeah, that is what I say. That's what I'm saying. That's the main reason why we have train and test. Train and test. Let us say the train data set, and it sees it, and Kolade sees it. Test is on scene. Even when I'm done with train and test, the other data set is on scene. It's on scene data set. I don't have it already. Sure, you get me. So what you just do is normal, bring in calling your stuff inside here. Just follow the code DF diabetes related data set, or any data set you are bringing in, and make sure the features are somehow related with this one you want to train with, right? Though there's a way you can do it, even though you are bringing any diabetes, any type of data set you are bringing, there's a way you can do it. If time permits, I'll teach us how to go about it. So you bring in data set, then apply the model that you have trained on that data set. Apply it on this new data set and see what it's going to give you. That's how you work. So we are going to work on inversion model 2. I'm not sure. Oh, I'm not sure. But if you want us to work on it, maybe next class, I don't know if I can include it, but because of time. So my own is also focus on the major something, and then see what we can do. Hello, sir. What can be done to improve the accuracy percent, the percentage of the model when we have 70? Now, again, for some of us, you can go and change the train and test data set, change it to 0.3, test size, change it to 0.3, or change it to 0.4. Make your test size to be 0.4, but make sure train is more than, and run it again. Run it again and see what it's going to give you, if the accuracy is going to increase. And next week, for read. Next week is upper parameter tuning. We're going to apply upper parameter tuning to see if our model is going to better. I like saying better, if the model is going to increase, right? So yeah, it will prove. Then quick answer, please. Where were you the one our instructors referring to that add 100% percent accuracy in your model while defending in Malaysia? Am I the one? I'm not. It was not in Malaysia. I think it's in South Africa. It was in South Africa. It was not in Malaysia. Kolade. All right, sir. Okay, yeah. Try it. For sir, web scrubbing, are we going deep to it? Also, web scrubbing, I'm not sure. Web scrubbing is simple. Paul, try it. It's very simple. Also, something that we think it does not matter, we remove it. You mentioned telling us how to do prediction from you used earlier. Eleni, I'm not sure of your question. I don't know. From you, user. And is it preferable to use research to train random forest, glaciers? I think you need that. Yeah, try it. You can try it, Adeleke. So something is to be one as to help some of us onboarding. The admin is going to help with that. This acknowledge, sir. Thank you. Okay. How many weeks do we have left for practicals, sir? We're doing practical already. I think next 2 weeks. Hey, Shegun below. Let me just attend to you before we go. Let me see that if I can before admin come and kick me out. Bah! So we have where's the code? You mean this? We have Shegun sec. Yeah, in training, okay. For DFT 121, 121, 121 is only 121, 661 outcome, which means diabetes, but in natural medicine, all the three are diabetes when fast blood glucose is used for medication. Okay, I understand it. Training the model, was fasting or random blood glucose use? Fasting is before eating. Random is after eating. Fasting. Okay, I think I'm understanding your question, Mr. Shegun. Generally, it's data sets. Actually, I'll keep it. It's just data sets. We have with data set. We don't know if the person fast. The patient, we don't know if the person fast or the person will not fast. So we just get the data set. Then we are applying our model on it, right? I'm not sure, DBC. So thank you for the class. Next week we're going to upper parameter tuning, and we still go back to training and testing, then train our model. Then, as I've showed you the first part, we use our model to develop something, and we're able to go. Thank you very much. Thank you for joining. And so there are many ones. There should be many ones. Run your code. Don't let be many ones. So thank you. God bless us all. Thank you for the class. Thank you so much.